Our next presentation is from System Level Solutions Private Limited, and it's all about from meters to cloud conquering development and connectivity. The presentation will be taken by Mr. Diptesh Patel, who is the Senior Manager, System Level Solutions Private Limited, and Mr. Lalit Shah, the Senior Manager, Systems Level Solution Private Limited. We will begin with Mr. Lalit Shah, though there is a lot to tell about them, but we will take up a few lines to describe both of them. Mr. Lalit Shah is a renowned expert in renewable energy solutions with over 5 years of experience in smart metering projects and in-depth knowledge of DLMS, COSEM. His expertise in integrating advanced technologies into practical applications positions him as a leader in addressing modern energy challenges. Lalit's contributions are vital to crafting impactful solutions that meet the demands of a rapidly evolving industry. Mr. Diptesh Patel, he is a distinguished professional specializing in the development of innovative IoT solutions. He has proven track record in designing and implementing robust software architectures for a wide range of IT-based products, currently having focus on the smart metering domain. He has demonstrated deep expertise in the head-end system and meter data management systems essential for smart metering. His profound understanding of these systems has enabled him to deliver seamless and efficient solutions that enhance data collection, management, and analytics for utility companies. With a passion for innovation and a dedication to excellence, Diptesh continues to drive advancements in the smart metering field, making significant contributions to the future of energy management and sustainability. Let's welcome Mr. Lalit Shah and Mr. Diptesh Patel on the stage.
Yeah. Good afternoon, everyone. I hope all of you may need a power nap after a lunch, because all of you have wake up early in the morning to reach to the event, and I am sorry, but I have to give the session exactly after the lunch. So I hope I may able to avoid your power nap. Okay, so we all have discussed why smart metering. Smart metering, why we need a smart metering. There are plenty of use cases of the smart metering. But the major, as we are discussing from the morning and hearing the word data, the main concern is of the data. How we collect the data. Once we have a data, there are plenty of opportunities with those data. We can utilize in that data in plenty of ways. So this is just a basic use cases and basic advantages of the smart metering. But it's not limited to this one only. So as initially discussed that, yes, it's not just to generate proper billing and disconnect the relay with the prepayment metering. That's not the use case of the smart metering. There are plenty of use cases associated with the smart metering. So we'll see in details how it can be useful. What are different ways of the smart meterings? What are the key components of the smart metering? So basically when we discuss about the smart metering, it contains plenty of components like smart meters itself, then its connectivity, then there would be a hidden system, network management systems, and at the end MDMS systems. Those are the main components of the smart metering. And there are different ways. Currently we are discussing about the electric meters. So those is AMI. While we have gas and water, that's kind of AMR. So just I will give brief architecture how AMI smart metering is work. So there are two types of communication for the smart metering. One is RF technology and another is NB-IoT and GPS. So what's the difference in the connectivity when it's NB-IoT or GPRS versus it's a RF technology? So when it's a NB-IoT or GPRS, the data will goes from the meter directly to the head-end system. While when it's a Wi-Fi or any RF technology, LPWAN technology, you need a gateway which collects the data and connect those data, and there would be network management server, head-end server, everything is required, and then it goes to data to head-end systems. And this is kind of AMI. AMR has similar architecture as well. So AMR, there would be a, that does not make the meter smart, but it reads the meter data and send it to head-end system. The way communication would be similar. The way AMI works with the RF, AMR works similar way in the RF, and NB-IoT and GPRS similar way send data directly to head-end systems for the AMR. So this is the key factors when we choose any technology. These are the different parameters that we need to consider when we choose any of the technologies. What latency performance we need, what scalability that technology can achieve, what is security provided by, what is the range provided by those technology, area coverage, infra deployment, overall cost, battery life, QS. If we consider that all technologies have pros and cons, and none of the technology can independently complete smart AMR. There needs a collaboration, like there are use cases where you need to use NB-IoT, where you need to use Eisen. You need to choose based on, there are plenty of parameters that required to choose based on the use case, deployment scenarios, where you are going to deploy, how your site is there, and that's all matters more instead of just like choosing from the beginning that I need to go with this technology only for this deployment. That depends plenty on the deployment site scenarios, where you have dense 4G network available, NB-IoT available, if you have to do scattered installations and all, that depends on plenty of parameters how you need to choose. And we mostly discuss on the designing challenges. So designing has common challenges every time. So if you have any meter, you need to design a NIC card, you know what you need to do. And you know have parameters, you have labs to measure those, you have trained engineers to design those products and develop those products. But deployment is completely a different scenarios. Where you deployment, we are lacking of the trained engineers to do the proper deployments. We need manpowers to do deployments, and deployment is every time it's different. If you go for one site and you apply the same logic for the second site, it will not work. You need to analyze each and every site independently of the designing technology and everything. So I will start with the basic main concern is of range for us. So if we consider range, then NB-IoT, if tower is available, it is in the range mostly. LoRa, we know that gives better range, but at the same time its packet size is less. It does not provide mesh supports, so it's not supporting IPv6. So it cannot be used for AMI, but it's very good suited for AMR, where you need less number of data to be sent, and it's providing very much battery efficiency. So none of the technology is contradicting, they are supporting each other, and you need to choose based on deployment and scenarios where you are going to deploy, which use case you are going to use, how you are going to utilize those, and those all parameters will decide how you are going to choose. From the infra deployment, I will discuss in detail for the case study, and that would be for RF technology deployment, because for GPRS and NB-IoT, it would be once tower is installed, and those dunes, before installing the tower, they will do a survey and they install a tower. That would be done by network operators. So that would be for them role, but as a technology partner, we need to discuss on how RF technology we can deploy. So I am starting with one of the case studies that we have done for the deployment scenarios. So as we know, then when the problems start, when the rubber hits the road, all problems will start. So when we have done everything in the office, we done plenty of testing and everything is working fine. But when we deliver and customer has started installation, we are starting seeing the issues. So how mesh network actually needs to form and how it has been formed initially. So this is one of the scenario which was how mesh network has been formed once customer has installed, and what actually we are looking for, that is that kind of scenario, where only 3 meters has been connected directly with one of the DCU and all other has been connected with the hopes. But what actually we offer, that more number of meters should connect directly with the DCU, and then it should move with limited numbers of hopes, and that's the next. Why it is so? Because latency will come into picture and network formation will take more time. When the network will work in both scenarios, and data, you will also get a data, but the latency will increase and there are power outage. If DCU is power outage and if that has been connected in this manner, it will take plenty of time to get a network establishment again, because meter has to process its data. Then we went into the field. We have done this kind of service with the tools, meters and all tools, and we found that some of the area which has been marked with the green, those are in getting good range, while the blue mark or something which is in the dark zone, where we cannot get 100% guarantee. Then we have changed the location of the DCUs. We have changed the height of the DCU installation and all. And then after again we got the similar graph which we were expecting to get on the range. But still after those, this survey will just give you brief idea. But you need to do data analysis on those of top. Still after those, there would be RF noise as well. That will also impact the performance of this. After site survey and everything, we got the proper map as well. But still, the number of data, continuous and accurate data which we need to receive on the head-end system, which was still missing after proper data and site survey and everything. Then we found that there is a noise which is also impacting. We have to change position of the DCU where we find there is a less noise. We have to move those DCU location. Even we have to find which filters we need to design which can reduce the impact of this noise, because if noise is there, your signal will distort and you won't get continuous signal connectivities. That will lose. If you have to send, like when prepayment balance is off, it should automatically disconnect the relay. But if you are having a noise and if your meter has been connected with 5th or 6th hop, there would be very difficult to send commands to the meters. Similarly, when customer is doing recharge and there is a noise and there is plenty of hopes, your meter has been connected, then there would be again issue of getting relay connected and everything. So with this one, like this was one scattered site we have done, and there are plenty of data which we have taken, and it will be over to Diptesh and he will provide how we have represented data and how we are going to analyzing those data and everything. Thank you.
Good afternoon, everyone. My name is Diptesh Patel, and today, as Lalit already informed, today I am going to discuss about how we can utilize hidden system and network management system also, that's cloud-based systems, in analyzing the network connectivity. So as our main topic goes, like conquering the network connectivity and deployment. So I will go to that later on. So in our first keynote presentation only, we heard from Mr. Sudhanshu sir, like the data collected from the smart metering ecosystem, that is going to be used by number of entities for number of different purposes, right? And till now also, like we heard lots of things on how to use those data, what purpose, how we can use that for the end consumer also. So those things are dependent on data. But the thing is that if the network connectivity is not reliable, then what will happen? The thing is that if the network connectivity itself is not stable or reliable, then the data collection, it will be compromised. So, I mean, as we know, like hidden system is the main key component, which is responsible for collecting data from all the meters deployed in the site. So the data collected by the hidden system, it will largely depend on the connectivity, network connectivity. If the network connectivity is not reliable, then definitely the data collection, it will get impacted, and we won't be getting proper data, which will eventually lead to the it will reduce efficiency in managing the metering ecosystem. So here, like here, as my friend Lalit explained, like we did like a RF site survey and all to improve the network connectivity. So the other part of that is like after the network has been deployed, and now we have started collecting data. So here I am going to explain like we can use our hidden system as well as the network management system also for analyzing the network connectivity which is there in the field. Like the, can I have that mic? Can I have that mic or? Thank you. Yeah. Am I audible? Okay, thanks. Yeah, so both like hidden system and NMS, they are mainly responsible for, hidden system is responsible for collection of meter data, and the network management system is mainly responsible for the entire, managing the entire network and representing the data of the entire network connectivity. So they help in identifying connectivity issues. So using those type of capabilities of HES and NMS, we can gain deep insights into the network connectivity also. So the purpose of hidden system is, main purpose is for collection of metering data, but other than that, like we can utilize the capability to analyze the network connectivity also, right? So here like there are some of the key, here are some of the key features of hidden system and NMS that will facilitate us for network connectivity analysis. Is for analyzing the network connectivity, and first of them is like real-time monitoring. So as the hidden system and network management system, both they will provide us real-time data from the entire deployment. And here we can see on the hidden system, we will show all the live data, like the recent data from the meter, which is what's the instantaneous data we can call for the meter. Energy meter, it's like the current, power, voltage, energy, power factor, it's what's the cumulative active energy and everything, and the daily consumption and all. So continuous tracking of meter communication, it will help us to detect and address issues promptly. So before the issue arises, we can identify and can take necessary action on them. The another benefit that we get from network management system, like data visualization. So from the network management system, it will help us to gain like how the current network has been formed. So based on that, like we can, from the NMS system, we can see this graphical representation, like how this blue one is the DCU, blue spot if you can see, and the rest are the nodes which are eventually connected with the smart meters, right? So here from the graphical representation, we can find out that the DCU is connected to different nodes in this way, as Lalit gave us a case study also. So those kind of things also help us in identifying the how the network has been formed, what's the performance of the network and all, what is the trend of connectivity, like how the meters are connected to the DCU via multiple hopes and all, right? Another one is historical data analysis. Yeah, so from the data collected in either hidden system or network management system, we can do lot of analysis of the the long-term trends and patterns. For example, here we can see one use case where it is, these are the uh, online scenarios for the DCU. This is one real scenario where the red spot, the red spot shows that during those time the DCU went offline. So based on this kind of representation, we can find out like what trend was there, how during what time the DCU or the power outages are there. Based on that, we can identify that the data that is going to be received from the ecosystem, we are going to lose those much data or whatever. So the network management system provides this kind of facilities, so using which we can work out more on the data, network connectivity, right? So another one is like remote diagnostics. So using these cloud-based systems, we get the ability to diagnose the devices remotely. So this also helps us in avoiding the physical requirements to access the meter or to access the node, and it helps us in saving the labor cost and all. Right? So here are some of the benefits that we can get using HES or NMS, that's the network management system or the hidden system for connectivity analysis. First is the increased reliability. So as I said, like if the connectivity is not proper, then the data that we are going to get, that is definitely not going to be as per expectation, and it will not give us expected results also. So that's the first thing, like we will get consistent data collection, which is the main role of hidden system, right? Another one is cost efficiency. So it, as I said, like it reduces the need for manual inspections and troubleshooting. So in the just previous example, we saw that we can identify the issues, or we can remotely diagnose or troubleshoot some of the nodes and DCUs and devices on the field remotely. So that will help us to reduce the cost associated with that. Another one is proactive maintenance. So that enables us to proactively identify and resolve the on-field issues. For example, in one of the previous slide, we saw that the DCU was not connected during those time. So whether it switched to the battery power or not, and how for how much duration the DCU was offline, all those kind of things we can gain insights using these tools. And based on that, we can do the proactive maintenance, like before that devices really go down and make the entire system down. So before that, we can take proactive actions. And the same thing is like improved decision making. So these valuable insights that we get from those kind of graphical representation or historical data, and using those data for analysis of the entire connectivity. So that will help us in improved decision making, like what we need to, whether we need to replace any device in the field to avoid any downtime. So all those things we can get better idea using these kind of tools. And so here also two scenarios, as Lalit explained, like before and after, like when we did the RF site survey, and also on-field required changes. So earlier the representation, we can, from this our hidden system dashboard, like we can get idea how many nodes are connected, how many of them are online, offline and all. So like from here only we can see that earlier the number of offline nodes were higher, but later on after we took all the necessary steps from site survey point of view plus other required steps. So then our the data connectivity that got improved, right? So that we can see from the online offline count of the meters. So earlier due to the improper connectivity, the meters were getting offline. That's the node were not getting properly connected with the DCU and the server. So this is how we can improve our connectivity by monitoring these systems. The same thing is here also. Like we all know, I mean, we know that we get push data from the meter automatically, and that we can configure like after every 15 minutes or 30 minutes or whatever interval. So based on this kind of analytics that we get from the data collected using hidden system or the network management system, we can identify like the push data count we can identify like total there are 10,000 nodes meters deployed in the field. So how many meters are from how many meters we are getting push data efficiently, and how many meters are from them we are missing the push data. So those kind of analysis will also help us in gaining deep insight into our connectivity, which is there in the field. So here also like we can see like earlier the push data count was it was only 40% devices were having push count above 95%. So which is expected as per SLA and all, it is expected that it should be above 95-97%. So from this analysis, we can identify like there is something there in the network connectivity because of which we are not getting expected data. So there we can work out on those things and then we can get proper data. So the idea is that we can utilize the hidden system or the network management system for analyzing the network connectivity also, besides its main role, which is data collection, right? Yeah, so I think that was from the network utilizing these two systems from network connectivity analysis point of view. And like this is our capacity and our subsidiaries. Yeah, thanks. So
थोड़ा आगे लीजिए